Okay.
Alright, well, so what we have here is a polarization reconfigurable microfluidic antenna. And I guess the main premise of this is to make an antenna that eliminates the need for tuner or coupler. So based on the change in environment that this antenna receives the EM waves in, which we're modeling using that screen, it should still be able to pick up whatever you send into it. So to reconfigure this antenna, we are using some fluids. These fluids here, we have oil and water, have different permittivities. So the difference in permittivities allow us to manipulate the EM waves and change how they behave in the antenna. So what this is doing here is it's passing this fluid through this microstrip patch antenna, and when it gets over the patch, the difference in permittivities changes the capacitance of these gaps in the patches and allows you to configure the EM waves. And on that poster we have like results of the radiation patterns and how it interacts with this patch antenna. And you can see that when the fluids are...
So that's a transmitter.
This is the receiver.
Receiver, sorry. That's a receiver.
That's the receiver.
So the receiver, basically the capacitor, the frequency is changing.
No, well, the frequency remains the same, but the polarization of the waves that it can receive changes.
The capacitor is changing?
Yeah, the capacitance is changing.
Dielectric is changing?
Yeah.
Okay.
And then, so this antenna should be able to receive whatever you send in, no matter what the transmitting environment is doing. Like I said, that's why we have that screen moving around. So, well, we have issues with this fluids mixing, and also we have some leaking. But we tested this and it works, so we have it here just to show that we actually have an antenna that we promised to make. So we went ahead and made a simpler version of it over there. That antenna back there is the receiver. It's a simpler version of this guy, but it wouldn't receive waves that you send at, in any environment, but it will still receive these waves whenever this gradient is horizontal. You can still change the polarization you send into it, but it can receive only certain polarizations. It can't receive just any polarization you send to it.
So can it be used as a means of detecting hazardous material, like in chemical warfare, if the air is polluted, right?
No. Well, I don't know if pollution in the air would really affect radiation patterns. I don't think so.
The transmitter is not going to pick it up?
No, the receiver would only pick up changing radiation patterns. It doesn't really... I don't think that if the pollution in the air affects radiation patterns, then it will pick it up. If not, it wouldn't really do that.
Can you demonstrate?
So, with this environment, try to send a signal through here, it's not going to receive it. It'll time out. You'll have no constellation where actually signals receive.
We're broadcasting here at 2.6.
So it doesn't receive anything.
Now you're going to turn it.
When it turns back.
So vertical polarization is blocked. This vertical orientation is trying to block this is actually the shield of the block
So here you're receiving. It's 4 QAM modulation right now. You're receiving the 4 symbols, and you can see all the transitions between those symbols.
Are these real time?
No, it's not real time.